All right, dividing real numbers. Okay, when dividing, okay, you follow the same rules for multiplying integers. Okay, same rules are these. When you divide by two negatives, the answer is positive. Okay, so number one. Number two, when you divide by one negative, the answer is negative. Just like multiplication, it doesn't matter which number's larger, it doesn't matter any of that. Okay, it's just a matter of the number of signs that you have. Okay, you could have, positive 1 million divided by negative 2, and you're still going to get a negative answer. Okay, it has nothing to do with the size of the number. It has to do with the number of negative signs that there are in the problem. Okay, now, another thing we need to remember is reciprocal. Okay, reciprocal is where you flip the number and then you multiply. So, for example, if I had this 10 divided by 2, or let's say 10 divided by negative 2, okay, that problem and this problem are exactly the same. Okay, they are equivalent. Okay, as in with most of the things that we've learned so far this year, everything's going to get harder. Okay, it's not going to be just a simple division problem anymore. It's going to be something that's obviously harder. Okay, they're going to start adding variables to the division problems. They're going to start adding expressions to the division problems. Just a lot of different things. It's going to get more difficult. Okay, so it's very important that you understand what reciprocals are, how we treat reciprocals, and we go from there. Okay, let's look at one of those, quote, harder problems. 3/2 over 2/5. Okay, that is a fraction. 3/2 over 2/5. But it's also just a division problem. We need to remember to look at that as simply a division sign. Okay? The fraction bar is just a division sign. Okay, so there's no reason to, panic on that. That's just 3/2 divided by 2/5. Okay? Now, obviously, they'll throw a negative in here or there, but it doesn't change what the fundamental principle is. Okay, that's 3/2 divided by 2/5. And so, therefore, 3/2 times 5 over 2. Okay, some of you missed this on the test the other day. When you multiply, you have to use the bottom numbers. Okay, you have to multiply 2 times 2, which is 4, 3 times 5, which is 15. 15 over 4, or 3 3/4. Okay? Now, if they threw a negative sign in there, it wouldn't really matter. It doesn't change what we do. It just changes what the final answer is. Okay? If they were to go in and put a negative right here, that doesn't change anything. okay, you would just put the negative, all the way down, and then it's right there. Okay, so it doesn't change anything with the negatives on how we do the problem. It just it affects the answer. Okay, and the only time it affects the answer is when there's one negative sign. That's, I guess that's the good thing about, division and multiplication. Realistically, the only time your answer changes is when there's one negative sign. All the other times, it's still a positive. Okay, whether you have two positive, two negatives, it's still a positive. Okay, so that is what you would call a complex fraction. Okay, but it's not as complex as it's going to get. Okay, so just remember that the division bar is just a division sign, or the fraction bar is just a division sign. That's all it is. Okay, so don't panic when you see it and go, I don't know how to do that. Yeah, you do. Okay, it's just a little harder, but you do know how to do it. Now, let's look at a couple examples. Let's look at this. D over 4 divided by 6. Okay, D over 4 divided by 6. They give you no value of D, so you've just got to simplify it. Okay, well, we simplify it by simply doing the reciprocal and getting D over 4 times 1 over 6. Okay, that's fairly simplistic. Okay, yeah, they put a variable in there. Oh, no, I don't know. It's just the same thing. Multiply straight across. Okay, D times 1 would be what? D. Okay. 4 times 6? 24. That's your answer. D over 24. Okay. Don't know what D is? Don't have to know what D is. Okay. So, don't panic on these things. They're very simplistic in a lot of different ways. Now, obviously, when we get to one like this, 42t over negative 14z divided by negative 6 over 7t. Now, obviously, that's a little bit more difficult than what we're used to. Okay, but it's still, the fundamental principles are still the same. Okay, you can throw all the variables, all the negative signs, all that stuff in there. The fundamental principles do not change how to simplify the problem. Okay, let's look at this one. So first of all, we've got to rewrite it. 42t over negative 14z times 7t over negative 6. Okay, well, first of all, how many negative signs are in the problem? 2. Okay, so my answer is going to be what? Positive or negative? Positive. Okay, so that should not enter into the equation as far as the difficulty of the problem. Yeah, I may forget to write it down, but it doesn't change it. Okay, what we want to look at is this. What you need to understand is this problem is that right? Yeah, okay. That and this those two things are exactly the same. Okay? They don't change. They're exactly the same problem. Okay? Now, our rules say that when we have multiplication, our property says that I can use the commutative property. Commutative property, remember, says that 2 times 4 and 4 times 2 are the same thing. Okay? So I can use the commutative property and do this. Okay, I can do that right there. Okay, I can rearrange it. Now all my numbers are on one side and all my variables are on the other side. Okay. Now this becomes fairly simplistic 7 goes into 14 how many times? Twice. Okay. 6 goes into 42 how many times? 7 times. Okay. So now, what I have left on top is 7 times t times t. On bottom, 2 times z. Okay? And then that is just 7 times t squared over 2z. And that's your answer. Now, it's positive because we had 2 negative signs in the problem. Okay? Now, you don't have to take that many steps. Okay? I am just showing you how and why mathematically I can do what I'm fixing to do. Okay? That is how and why I can take that problem and reduce it down to the final answer. Okay? Larry? Well, because we don't have to mess, that's what I'm saying. We've got 2 negative signs in the problem. So we already know our answer is positive. You don't even have to, realistically, if you wanted to do this, if you come up here and see this, and you just want to come down here and go ahead and go, okay, I'm going to put a plus sign down here, that lets me know it's positive, and then don't even worry about the negatives the rest of the problem, then do that. Just like if we would have taken one of those negative signs out, I'll just go down to the bottom and put a big negative sign, so that just, reminds me, hey, it's negative. And then when you get the answer, put the negative sign in there and don't worry about the negatives. Okay? Because in this particular instances, when we're dealing with just division, it doesn't matter. Now, if you had some addition thrown in there somewhere, then you've got to keep track of them. Okay? Let's look at another one of those types of problems so I can show you the way that I would prefer you to do it. Let's look at number 43. Number 43 says, let me get back to regular writing. Negative 54x squared divided by negative 9 over 5. Obviously not as complicated as that last one, but it's still, a little bit more complex than we're used to. Okay? Now, so if I rewrite the problem, that gives me negative 54x squared over 1 times negative 5 over 9. Now, understand, negative 9 over 5, negative sign out in front, 9 over 5, or all those are exactly the same. These are all equivalent. Okay? Every one of those expressions there are equivalent. They're the same. So it doesn't matter if I stick the negative sign in the top of my fraction, the bottom of my fraction, or in the middle of the fraction, it still represents the same thing. Okay? So the fact that I changed it from the 9 here to the 5 down here does not change the answer or the value of the number. Okay? But we do understand that we have 2 negative signs, so my answer is going to be positive down at the bottom. Okay? Brandon? Yeah, hang on. All right, now, all you have to do is treat this like a regular fraction problem. Cross cancel. Okay? A while ago, I just showed you why I can cross cancel. I did all the commutative property and showed you. Now just cross cancel it. Okay? 9 goes into 9 one time. 9 goes into 54 6 times. Okay? There are no variables, so I can't reduce any of them. Okay? And so that would give me on top negative 6x squared over 1 times negative 5 over 1, which that gives us 30x squared, positive. Okay? Anybody not understand where I got that? If you do, don't hesitate to ask, because sometimes I go too fast, and maybe I need to slow down. Okay, now let's look at that problem again. Let's say I had this. Let's redo that problem. Let's say it was this. Let's say it was negative 54x squared over 1 times negative 5 over 9x. Okay, let's say I had that. Doesn't change. Okay, I can still, let's make that negative, so it's everything but the x is still the same. Oh, it is negative, my bad. Forgot I had it there on my 5. Now, same thing. 9 goes into 9 once. 9 goes into 54 6 times. Well, let me show you this right here. If I had x squared over x, okay, well, that's the same thing as x times x over x. Well, I can cancel those two out. Leave me 1x on top, right? Okay, and so then that would mean I had this. Negative 6 times x times negative 5 over 1 times 1, which is still negative 30x now over 1, which is just negative 30x. So the only thing that does is it just takes away one of my x's, okay, because I can cancel it out. Owen. Oh, yes, positive. Thank you. I keep thinking I did just put one negative in there. Okay, so it's just 30x. Doesn't change anything. Okay, you can treat the variables just like you can the numbers. All right, let's look at another example. I want you to do 42 on your own. Do 42 on your own. It's 68x divided by negative 17 over 9. All right. We go 68x times negative 9 over 17. Okay. Then we just cross cancel. 17 goes into 17 once. 17 into 68 goes 4 times. That leaves me with 4x over 1 times negative 9 over 1. Now I just take the 4 times the 9, which is negative 36x. Okay? All right, now, let's look at these expressions. Here we go. 45 minus 5x over 5. Okay? And they want us to simplify that. 45 minus 5x over 5, and they want us to simplify. Okay? Now, here's what I've got. Okay? I am going to divide those into that. The 5 into the 45 and the 5 into 5x. Here's why I'm going to do that. Okay? 45 minus 5x divided by 5 is what that expression is. Okay, that's the horizontal version of that same problem. Okay, well, that means I got to do this. 45 minus 5x in parentheses times the reciprocal of 5, which is 1/5. Okay, now I'm going to use the distributive property. I'm going to distribute to both of those. Okay, and so that gives me 1/5 times 45 minus 1/5 times 5x. Okay, well, what is 1/5 times 45? 1/5 times 45 is just 45 over 5. Okay, all this is right here is 45 over 5, which is 9. Minus all this is 5x over 5. And that is cancel x. Okay, so my answer is 9 minus x. Okay, and if we go back, if we look at this portion here, if we look at this portion right here, okay, that's the same thing I said up here. Okay, divide 5 into both of the terms. Okay, it's the same exact thing that I said up there. That's why we can do it. Okay, now let me show you how you can do it without having to do all that. Brianna, do you have a question? No, right? There you want to leave it like that. Okay? In fact, the more and more we go through this, the more and more you need to understand that anytime we have something like this, okay, whether we're starting out, you need to understand that's plus and negative. And if you can get to a point where you don't have to change it over, you can see it, then I would prefer you to be there, because that's where we're trying to get to. Okay? Like, for example, people I taught in 11th grade now, that I taught back in 7th grade, 8th grade, okay? They don't do that anymore. They just understand that the minus sign is really plus and negative, and they're able to do it without having to change it over every time. Okay? When you can get to that point, do that. That's fine. Okay? Now, let me show you how I want you to do this problem without doing all that extra. Okay? Let's look at number 50. Number 50 says negative 56 plus x over negative 8. Okay? Here's how I want you to divide this problem up. Okay? We are going to do what I said. We are going to take and divide 8 into both the terms. And so that gives me negative 56 over negative 8 plus x over negative 8. Okay? Now, negative 56 over negative 8 is what? 7. Plus x over negative 8. Can I divide that into it? No. So it's just x over negative 8. Okay, now, I believe, let me make sure how they want you to express the answer. Yeah. They're going to want you to express the answer just like that with this exception. This is what I just talked about with Brianna. There's a negative, there's a plus sign. So that's got to be 7 minus x over 8. And that's your answer. Okay, because it applies to the fractions just like it does the whole number. Okay, if we would have had 7 plus negative x, we know that that's 7 minus x. So this same thing applies over here. Okay, plus a negative on a fraction is still the same thing. Okay, Nick? Yep. Yes, you could say 9 minus 1x. I would prefer you not to, okay, because that's another one of those things that the further along you get, the less things you can put in there that you don't have to put in there, the better off you're going to be. Okay, when we get to some, larger problems this year. There'll be problems this year, folks. I'm not going to, there'll be problems this year that'll probably take up, if we work downward, they'll take up probably 8, 9, 10 lines. Okay? That's a lot of stuff to write. Okay? It is. Because in a little bit, we're going to get into multiplying fractions, and you're going to have 4 fractions that look like, I don't see any really that difficult. You're going to have 4 fractions that it's just going to be crazy. Okay? But we're obviously we're not going to just say, hey, you got to know how to do this. We're obviously going to teach you that. Yes. Down. Okay.
On the
56 what now?
56 plus x over negative 8.
Uh-huh.
Why do you add it?
Why do I add it?
Yeah.
I didn't add it. I didn't add anything. I divided.
No, why didn't you multiply it?
Okay, show me on the screen. What are you talking about? I'm obviously not understanding. Why did I add it?
Yeah.
Okay, because of that sign right there. I just brought that sign down. Okay? So if that would have been a minus sign, it would have just said minus. Okay? You're just bringing, in other words, all I'm doing is splitting the two things up. And I'm putting an 8 on each one of them, on each of the bottoms. Because here, and this is what you need to see. If I had this, if I had that right there, 3/4 plus 7/4, isn't that the same thing as 3 plus 7 over 4? Okay? So realistically then, what I have right here, this is the same thing. I just got a variable in there now. Okay? And that's my problem. I've got a variable, and it sort of throws people off. But this problem here, 3 plus 7 over 4, is exactly the same as that problem there. Okay? That's just what we can do with fractions. Okay, any other questions? All right, let's quickly talk, because I'm running out of time. Yep. Let's quickly talk about our formula from yesterday. Displacement was equal to what? Was it displacement equals what? Vertical displacement, right? It was vertical displacement equals velocity times time. Okay? Well, what they're going to want to know today is they're going to want to do velocity. They want to find velocity. So to find velocity, I have to divide by time to both of these sides to get velocity by itself, correct? Okay, so velocity then is going to equal displacement over time. Okay, so they're going to give you some problems today that you're going to have to find the velocity, how fast they're ascending or descending, and it's simply the displacement, how far did they go over the time. Okay, and so I wanted to just touch base on that, and it's a fairly simplistic problem dealing with rockets and things of that nature. And so you're gonna need to do that. Now, let's look at, here's your homework. Okay, I'm glad you're pumped up about your homework. Glad everybody's pumped up about that. I don't think I have it printed out, but there it is right there. All right. 2.7. 16 through 46 even. 48 through 57. 62 through 64. 68 through 70. Okay, so that's going to be 16, 15, 25, about 30 problems. Okay, you may go.